Hi everybody. I think it's almost 8:30 right now, and I just get a message from one of the students. He said, "Hey, my name is Tavish. I have a problem. I have a questions here. Could you please help me out?" So it's almost like I say, past 8 right now p.m. Past 8 p.m. and let me try to have the base that I could. So I'll try to explain the base that I could. So let's, without wasting time, let's get back to the question. Let's get back straight to the question. So there's a question right here. Let me turn my camera quick. Excuse me. I hope everybody can see. So that's a question right there. The question say, this is a question two. He say, Image, his name is Tavish. So he said, please, Image, could you help me with that question? So the question say, he says question two, according to how he say. Say the first time, say this question is due tomorrow, Hamish. And he right here, study Reading International School, International Reading International. I do A level Cambridge syllabus. So I have a problem with this question. Please, could you please help me? Yes, I could. So the question say, hold on, what's the time? They say the first term of arithmetic progression is A, and the common difference is D, whereby D is not equal to 0. Okay, so they say write down the expression in terms of A and D for the 5th and the 15th terms. Okay, let's get back to the business. Let's go to the business, right? So I'll push this aside a little bit. Excuse me, first question. So first of all, I want to explain to you arithmetic. I'm not going to start the whole arithmetic. I'll just show you how to get terms in arithmetic. The Tn formula to get any term in arithmetic, we say Tn A n minus 1 times D. That's a formula to get any term in arithmetic series. Okay, arithmetic sequence series. Okay, so look, this D should not be equal to 0. You know why it should not be equal to 0? Because when this equal to 0, say D equal to 0, means everything here is going to be 0. So means our term n is going to be equal to only A. See, so for that reason, that's why they have explained that D should not be equal to 0. So this arithmetic term, whereby Tn means it can be, Tn means number of terms, can be term 1, term 2, term 3. A is the first terms. N, how many terms? If it's 5, you put 5 here. D, the common difference. So common difference, how do you know something arithmetic sequence? For example, if I have a 2, 4, 6, 8, this is arithmetic sequence because if I take 8 divided by 2, it should be same with 6 minus 4, and it should be the same with 4 minus D. So that's what we call common difference, which for this case it will be 2. Let's go to the question now. What was the time? Excuse me. So now they say the first term of go back a little bit. The first term of arithmetic progression is A, and the common difference is D, where D should not be equal to 0, just like how we see, because there is 1 there. This should be 0. So write down the expression in terms of A and D for the 5th and 15th term. Okay, excuse me, for the 5th and 15th terms. Okay, so we're gonna write our formula for arithmetic. How we say Tn equal to A. I hope everybody can see. If you cannot see, please let me know. Let me push this a little bit. Ta to A n minus 1 times D. But what do the one? The one they write down the expression of it for the 5th term. So here is 5. So we're gonna say T 5th terms means 5. So our A, n here is not gonna be n anymore. It's gonna be 5 minus 1 times D. So now we're gonna say this m equal to A plus 5 minus 1 equal to 4D. So 5th terms equal to A plus 4D. So that's the 5th terms of arithmetic. Excuse me. Okay. Now 15th term, they say 15 and 15. So for 15 is gonna be T. So here is gonna be 15. T15 is equal to A. It's just A plus, and here is going to be 15 now. So 15 minus 1 times D. So the same as say A plus 15 minus 1 equals 14 D. So this is 10 15. So we have a temp 5 and temp 15 of arithmetic. So the first part is done. So now we go for the second part. So the A, the first part is done. We're done already. So we go for the second part. So for the second part, they say the first term and the fifth terms and the 15th term of arithmetic progression are the first 3 terms of geometric progression. Means the first term, second term, and 15 terms of arithmetic progression are the first 3 terms. Of geometric progression. Okay, show that 3a equal to 8d. No, that's easy. Okay, let's go. So he say, Hamish, I'm having problems, especially for the second part. It's easy, man. Let's go. So I'm gonna pull this on that side right there. They say first term. So I'm gonna say, okay. So if this is arithmetic, let's say this is arithmetic and this is geometric. Then put like that. So this is number 2, second part. Let's say that's arithmetic and geometric. So what they're trying to say is the first term, 5th terms, and 15th term of arithmetic means, excuse me. Oh my goodness, just move that. Arithmetic first term will represent by A, and and then they say 5th terms. What are the 5th terms? Term 5. But we had a term 5 from the previous question. We say term 5 equal to A plus 4D. So I'm going to say okay. So this is 5th terms of arithmetic, and then we say 5th. This is first term. 5th terms, we have the value of 5th terms, which is A plus 4D. And they also say 15 terms. They continue say 15th term of arithmetic progression. Okay, so now we're going to write 15 terms here. So we're going to say A, which we have here, A plus 14D. 14D. So these are equal. They didn't say equal there, but they say are the first 3 terms of geometric progression. Okay, so these for geometric. Okay, let me show you quick geometric. If you want to get terms in geometric, we use this formula right here. Excuse me. If you want to get terms in geometric, we use this formula here. Excuse me. Here we use Tn equal to A out of n minus 1. So if it's term 2, we're going to say term 1, for example, we're going to say T1 equal to A out of n is 1, so 1 minus 1, which is going to be equal to A out of 1 minus 1 equal to 0, but any number power 0 equal to 1. So it's just A times 1 equal to A times 1 equal to A. This is term 1. So term 1 for geometric equal to A. Okay, term 2. Term 2 is A out of, but we say is n minus 1. So we're going to say 2 minus 1. 2 minus 1. Which equal to A out of 2 minus 1 equal to 1. So A out of. So that's a term 2. Term 3, we do the same thing. So this is going to be equal to A out of 3 minus 1 equal to 2. This is term 2. Term 3, my fault. So A out of square. So according to the equation, excuse me. The equation they say the first term, 5th terms, and 15th term of arithmetic progression are the first 3 terms of geometric progression. But we know the first 3 terms of geometric progression. We just found them now, right now. Or should I find them again? No. Go say term 1 equal to A out of, see, because we use this formula here. So term 1 equal to A out of, or let me do it again just in case. But I hope everybody knows. So term 1 A, because they say the number of term formula, so we say Tn equal to A out of n minus 1. So if it's 1, we're going to say 1 A. Our n is going to be 1 minus 1 equal to 0. So A out of, so n number for 0 equal to 1. So it's just A for term 1. For term 2, we put 2 here, which is 2 equal to A out of n 2 minus 1, which equal to 1. So it's just A out of. Term 3, we do the same thing here. It's like how I say term 3, we use the formula also. We say A term 3 equal to, we use this formula here. Everybody can see that formula right there. So we're going to say term 3 equal to A, just A out of 3 minus 1 equal to 2. So this is term 3. So we have term 3, term 2, and term 1, which equal to A. So for that case, Good. Let's go. So we say for that case now, we say a first term of geometry of arithmetic equal to first term of geometry. Second term is gonna be a ara. But the first term of arithmetic equal to first term. First term of, how did you know that is equal to first term? Because they say here the first, fifth, and 15th term of arithmetic progression are the first three terms of the geometry. First three terms of geometry. So first one is going to be equal to the first one. Fifth one of arithmetic is going to be equal to the second of geometry. 15th of arithmetic is going to be equal to third of geometry. Okay, so we're going to say, let me put this one right there, man. So this is going to be equal to a ara. This is going to be third one. So n is going to be 3. 3 minus 1 equal to 2. So we got three equations now. We got three equations. So prove that. Remember, if I take this term, divide by this, because remember geometric progression to get a common ratio. So this is term 1 for geometric, this is term 2 for geometric, and this is term 3 for geometric. But I know for any geometric progression, if I take term 3 divided by term 2, it must be equal to term 2 divided by term 1. So let me do this. So I'm going to say, okay. So I'll say a ara square over a ara, it must be equal to a ara over a. This over this must be equal to this over this. Now I'm going to write in is same as a equal to this over this and this over this. So let's say same as a equal to a plus 14d over a plus 4d. Then it must be equal to this divided by this, which is a plus 4d over a. So for that case, we see the 1 ara, a and a cancel. So ara equal to ara. Oh, ara equal to ara. Now we come here, we can't cancel anything. So we say ara equal to a plus 14d over a plus 4d, a plus 4d, this is a, my handwriting, man, plus 4d equal to a plus 4d over a. So now since I just want to prove 8a equal to 3a equal to 8d. So what I'm going to do right now, I want to prove 8a equal to 3. So what I'm going to do, I'm only going to, because this equal to this one equal to that one, so I'm only going to deal with these two. I don't need to deal with this one for now. So I'll take this and this, because they're equal, so I'm going to cross multiplication. So if I cross multiplication this and this, I'm going to say, okay, so a times a is going to be a times a, or I can just put bracket. They say a times a is a squared, and then plus a times 14d is 14 ad equal, okay, now multiply these two. A times a, you can cross slowly, right? Just do straight away, but just, okay, let me go slowly. I don't want you to say, oh, I didn't understand. So say a times a squared, a times 4d plus a times a squared, a times 4d, 4ad. Okay, so 4ad. Now you count for the second one, the first one, it's going to be 4a. 4 times going to be 4d squared, 4d squared. Sorry about that. Okay, so these and these are similar, so cancel. So now we're left with 14ad, 14ad, right? Okay, 14ad. I think I multiplied wrong here. A times a is a squared, and then a times 4d is 4ad. Now we come here. Oh, I forgot d here, that's why it don't make sense. You see this d here? I forgot here. So it has to be a times a is a squared, and then a times 4d is 4d, and then you count 4d times a, 4ad. There's an a there, and then 4 is going to be 16 here. The last one, it must be 16. Apologies, 16d squared. Okay, so a and a cancel, and then these two is going to be 8ad. So we're going to have a 14. Oh my goodness, 14. I hope everybody can see that, right? So 14 AD equal to 80 AD plus 16 d squared, but you can multiply very slow to get an accurate answer. So this 80 comes here is going to be 14 AD minus 80 AD is going to be 6 AD equal to 16 d squared. Okay, so let's simplify now. 1d and d cancel because d and d, my apologies, I cancel a and d, my apologies. Is d with 1d, so we're gonna left with 6a equal to 16d. Divide, simplify, so finally it's gonna give us 3a equal to 80d, and we have proved. So we're gonna check the last one, last part quick. Okay, so we have seen that it's true that we have seen that 3a equal to 80d. So I'm saying, so we just cross here and we get 3a equal to 80d. So the second part is done. Just in case if you don't understand, please let me know. So the last part, they say find the common ratio of the geometric progression. The common ratio. So to get a common ratio of geometric progression, look, I'm going to take from this term here. So it's this one. Okay, so I'm going to say, okay, to get a common ratio from this part here, right here. Well, we have R, excuse me, R. I'm going to put right there. R equal to A plus 14D. That's how we get common ratio. Means you take, how do you get common ratio? Second term divided by the first term. Third term divided by the second divided by the first one, which you got them this one. So I'm gonna take, we got common ratio equal to A, common ratio equal to A, I'll take this one here. Excuse me. So let me call this tie equation here. Let me call this tie. That's this tie. So say take this tie equation, which is a R equal to A 14D over A plus 4D equal to A plus 4D over A. So whichever one I'm going to take is going to give me common ratio, and we know here 8d equal to 8a equal to 8a equal to 8a equal to, come on man, what am I talking about? 3a equal to 8d. My apologies, sorry, just spell error. Okay, so we're going to say, okay, but we use our pen here, but 3a equal to 80d. So now I can substitute this stuff in here, in end of this. So I'm gonna say, okay, so let me make subject A here, and then I can come and substitute the value of A here. Or I can make D and then come and substitute the value of D, whichever you want. So I'll make A. So by my A equal to 80D over 3. That's the value of A. So what I'm gonna put this on, I can put it here and there to get a common ratio, and so I can put here and here to get a common ratio. So I'll say my common ratio equal to A. What is my A? 8D over 3 plus 14D. So over A equal to 8D over 3 plus 4D, which is the same as A. What is my A? 8D over 3, this is my A here, plus 4D over A. So now we can just do normal fraction. These are like terms, so I'll just say 80 over 3 plus 14, or let's do systematic. So we say R equal, you can take D out here because the common thing, so we're left with 8 over 3 plus here is going to be 14 over, same here, I'll take D out here at the denominator. So I'll be left with denominator 8 over 3 plus 4, which is the same here. I can take D out, so I'll be left with 8 over 3 plus 4 over, come on man, I forgot to place here the value of A, sorry. So it should be 80D over 3 here, it should be 80D over 3, so I'll use that pen here. So this should be 80D AD over 3, 8. So here if I take D out for the first one, for this one here it should be 80 over 3. So D and D cancel, D and D cancel. So this divided by this must be equal to this divided by this, and that's your common ratio. So you can plug that in a calculator. So my common ratio equal to take a calculator, plug that out, or we can just do like grade 1. Come on, plug in the calculator, man. So plug that in the calculator and you're gonna get your common ratio, and that's done. Plug in the calculator. So what we have here on the face on, so say it's 8/3, so we say fraction, excuse me, on, and then 80/3, 8/3. I hope everybody can see that. That's 8/3, and the plus 14, excuse me. No, so let's say put fraction, and the denominator is 8/3, so 8/3, 8/3. You can plug in a calculator, please, man. I shouldn't even do this one. Everybody could do this one. Plus 14, plus 14, and then over denominator is 8/3, so it's 8/3 over 3 plus 4, plus 4, which equal to, see that, is 5/2. So even the second one should give you the same thing. So common ratio equals 5/2, which the second one should give the same answer also. Okay, this is the second one, you see. So give 5/2. Can do this. So also is gonna give 5/2. So our common ratio is 2.5. 2.5. And we done already. So yeah. Hey Tavish, I hope I tried my best to explain to your question. If you didn't understand, please let me know. I can try to make another video to make you understand. And thank you so much for your time. I appreciate it. Feel free anytime you have a question, please guys, send question here. We need questions, man. We're starving for the questions. So send the questions, bring the questions. Thank you for your time, and I appreciate it. So, and don't forget to leave the comments there. Like I say, you might learn from a mistake. If you identify or you learn from a mistakes, and also you learn, I believe you learned quite a lot from me. And a problem, let me know anytime. Bring the questions.